A lift of mass 100 kg starts moving from rest in the upward direction. The diagram shows the variation in the speed. If T1, T2, T3 are the tension over here in the rope from 0 to 2 seconds, from 2 to 6 seconds and between 6 to 7 seconds respectively, then we have to calculate the ratio of T1 is to T2 is to T3. So basically, if I draw the diagram over here of a lift, so basically if this is a lift, now this is moving upwards with whatever is the acceleration. Let us say the acceleration is A in this case. Okay, let us say the acceleration is A in this case. It will be mg in the downward direction, there will be tension in the upward direction. So basically over here the tension will be equal to, in the first case when the lift is accelerating, you can see from 0 to 2 the lift is accelerating in the upward direction. So basically in this case, in any case, T minus mg can be written as ma. So over here T will be equal to mg plus ma. So over here T is equal to mg plus ma. Now m is equal to 100, g plus a. The g over here is equal to 10. In the first case, let us find out the acceleration. Acceleration will be given as v2 minus v1 divided by t2 minus t1. So basically over here it will be equal to 4 minus 0 divided by 2 minus 0, which is equal to, in the first case the acceleration is given as 4. The acceleration is given as 4 divided by 2. Okay, 4 minus 0 which is equal to 4, 2 minus 0 which is equal to 2. So it will be equal to 10 into 2 which is equal to 12. So it will be equal to 120 Newton. In the first case it is equal to 120 Newton. In the second case, the acceleration of the particle is equal to 0, because you can clearly see from here that the velocity is not changing. So the tension only will be equal to mg, which will be equal to 100 into g, which is equal to 10. So basically it will be equal to 1000. So 100 into, in the first case it will be 1200. Okay, in the second case it will be equal to 1000 Newton, and in the third case the body is accelerating or deaccelerating. In this case it will be equal to 7, it will be equal to 0, that is this point, minus 4 divided by 7 minus 6. Okay, so in the third case the acceleration will be equal to 0 minus 4 divided by 7 minus 6, which is equal to over here 0 minus 4 divided by 7 minus 6. So it will be equal to minus 4 meter per second square. So basically the body is deaccelerating. So in the first diagram there will be only one rectification, that is acceleration is in the downward direction. If the acceleration is in the downward direction, if the acceleration over here is in the downward direction, then for this case mg will be greater. So mg minus t will be equal to ma. So t will be equal to mg minus ma, which will be equal to, t will be equal to mg minus ma, which will be equal to 100, g minus a, which is equal to 10, acceleration is equal to 4, which is equal to 4 over here. So it will be equal to the acceleration over here, the value will be over here, it will be equal to 600 Newton. So if I take the ratio, in the first case it is equal to 1200, in the second case it is equal to 10, it is equal to 1000, and the third case is equal to 6. So basically if I take the ratio, it will be equal to 12 is to 10 is to 6. If I divide it by 2, it will be equal to 6 is to 5 is to 3, which is option number B.